Hello everyone, welcome back again. So in this segment we are going to see how to draw the relationship diagram. So we did listed all the relationship that we found from our software project requirement and from our initial design. Okay, so this will be our final product, but don't be scared because we are going to actually show you all the step-by-step process how we are going to get to this point. All right, so as we said that actually from the initial design, from some of the attributes, we are going to find out the relationship. For example, like department has a manager attribute. Manager is actually manager comes from another entity, employee. So that means it's a relationship between department and employee. So works on is an attribute. Was an attribute from the employee table. So and this works on actually connects with the project. And employee has also a department table, department attribute, and the department attribute comes from the department entity. So that will be a relationship between employee and department. So more than one relationship type can exist between the same participating entity types. For example, like between employee and department, there are actually two relationship. So the managers also connects both employee and department, and works for also connect employee and department. Okay, but the relationship but they are actually different type of relationship, right? So so between the employee and department, we can have two different type of relationship. So the manager will be the managers. It's a relationship. Some employee works as a manager for a department. Each employee works in at least one department. Each employee is going to works at least one department. So these are the two different form of relationships. So we have to actually show that by using two different relationship types. Okay. So these two relationship has different meaning, so the instance will be also different. We can have recursive relationship type. Recursive relationship type means if we have the same entity types in both sides. For example, the supervision. Okay, the supervision relationship connects employees with employee. So it looks like that. It will look like that. Supervision, the employee in this side and employee in another side. Okay, but here the role is different. So in the first side, if the role is supervisor, the second side the role will be supervising. All right, and it should be actually clear from our diagram that that who is supervising which employee. Okay, so one way to do this is like that, where we have to actually specify the role in both side, or we can also, or if we are going to show the relationship like that, we have to actually depict the different relationship like with a labeling. For example, like here the level 1 is the supervisor role, the level 2 is the supervisee role. Okay, so we'll talk about weak entity types, but before that we want to talk about different constants on relationship. So in the relationship type, we can have two different type of constants. Cardinality ratio will specify the maximum participation on both sides. We can have three type of cardinality ratio: 1:1, 1 to many, or many to 1. They both are actually same, and many to many. So 1 to 1 says that on each side only one entity can participate with other side. Okay, so on the relationship we are going to show them like that. So one-to-one says that one entity from E1 one entity from E1 entity type can participate in the relationship. They can participate with only one entity from E2 type. Okay, so one to many says that one to many, or one to n, we write that like one to n, says that one to many. So one participants can so one entity from E1 set, E1 type, one entity from E1 type can participate with multiple entities from E2 type. Okay, and the same thing from E2 to E1, we can say that as a n to 1. All right, so vice versa, if we can say that multiple entities from E2 types can participate with only one entity with E1 type. And M to N is the many to many relationship. So many entities from this side, E1 type, can participate with many entities from E2 type. So we will see example. Let's see a couple of example. Say one-to-one relationship. Let's think about the relationship between. Let's see a couple of practical example. So let's see we have a set of wife, and we have a set of husbands. Okay. So in the practical world, in the real world, we can have, in the ideal practical world, so each wife can have at a time can have only one husband. Okay, so this participation will be like that. Each wife can have only one husband, and each husband can have only one wife. Okay, so this is one on both sides. So W1 has one husband, H1, so W1 cannot have any other husband. So let's say W3 has H2, only one husband. So W2 should have another husband like H3. Okay, so each wife can have only one husband, and one husband can have only one wife. So that's one on both sides. Okay, so that's a one-to-one relationship. Now let's think about a relationship between mother and children. Okay. So these are the list of biological mothers, and these are the list of children's. Okay, and also biological children's. So one mother can have multiple biological children. We are saying that one mother is allowed to have more than one biological children. It could be any number from 1 to many. Okay, and it could be any number actually from 0 to many. Okay, so one mother is allowed to have any number of children. All right, let's say M1 has 3 children, M2 has only 1 children, and M4 has 2 children. Okay, so that's n, many on children side. One mother is allowed to have many children. But what about the children to mother relationship? One children can have only one biological mother, right? So one children can have only one biological mother. So C1 has M1, his biological mother, means that's only one participant. So C1 can have only one biological mother. So that's one on mother side. Okay, so that's a one to many relationship. All right, so remember, it's actually specifies the maximum participation. So some mother may not have any children, but that's okay. But the mothers are allowed to have more than zero or any number of children. Okay, but each children will have only one biological mother. Now, if we reverse the role, like children to mother, we'll see that each children will have only one biological mother. Okay, each children will have only one biological mother. So C1 has M1, so any other M2 cannot be his mother. So C2 has mother M1. Okay, so C3 has M1, his mother. Fine, but M1 can have more children, but each children can have only one mother. Okay, so that's 1 on mother side, that's n on children side. So that's actually the same thing, but if we just reverse the role, that will be like many to one relationship. So this is 1 to many, and the same relationship, just reversing the role, it will be many to 1. All right, so we can have many to many. For example, like we are thinking about siblings. Okay, say brother and sister. So we have sister on this side, we have brother on this side. Okay, so one sister can have a multiple brothers, and one brother can have multiple sisters. Okay, so that's many on both sides. So many, so many to many, it says that many to many relationship, and we represent that like as a m to n. Okay, so that's a m to n relationship, means it's a many to many relationship. Okay, so from the relationship constant, the first type of constants in cardinality ratio, we have to specify the maximum participation. Cardinality ratio specifies the maximum participation. Okay, we saw the examples from 1 to 1, 1 to many, many to many, and in our year diagram we have to actually specify those type of restriction. Another type of constant is known as existence dependency constant, and that will specify the minimum participation. Okay, and we'll talk about that in the next segment.